Welcome back. This is Mr. Hassan's Maths channel, and I'm going to be answering some questions now from this mechanics paper 4 from the specimen paper for the Cambridge 9709 exam. This is for the examinations from 2020 where the syllabus changed. And I'm going to be answering these questions from this paper question by question, so that I can save them in the playlist for the paper itself and another playlist for the topic which the question is from. So I can make multiple playlists from it, and that might be saved in ways that are useful for people. Now, so one little word of caution for those of you who think I'm just going to just basically recite the mark scheme without explaining anything. Well, this is not the place for you. Right? If you want to look at the mark scheme, you can download it and read it yourself, or find someone else who does that. I'm going to actually take my time to try to explain the concepts, because I'm doing this as a way of helping my students that I'm teaching in school, and those students who, weren't paying proper attention probably in class, or, they need some extra support, or those students, who, really need to learn the foundations, who maybe I'm not teaching, who are from other places, and they don't have access to teachers or whatever, and they're homeschooling, whatever. So those type of people as well, those are the people in my mind when I'm explaining these. And sometimes I go through a concept because of questions I've been asked by my students. Okay, they've asked a particular question, so I might kind of concentrate on a particular aspect to highlight it and to explain that particular aspect of a question. Okay, so that's just, as I said, a little warning for you. So don't expect me to take, just walk through the paper by reading the mark scheme. I'm going to be explaining the concepts and the backgrounds, and try to, give some tips as well. So that's just something that you should understand before we start going through these videos. Now, I'm going to start with question number 1. And question number 1 is: a particle P is projected vertically upwards with a speed of 20 meters per second from a point on the ground. Find the greatest height above the ground reached by P. Okay, so here's a question about vertical motion under gravity. Right, so what we do is we take the ground level. I'm going to take this as the ground level. I'm going to call this G. And it's going to get to a level, the highest point that it's going to reach. And I'm going to call that level up here, let's call it H. In fact, I'll draw it off that line so it looks. So that's the level H. Okay. Now, from the ground, it's projected upwards with a speed of 20 meters per second. All right. We got to find the greatest height above the ground that it reaches. Okay, now the greatest height above the ground that it reaches, it's going to be this distance here between what we call G and H. All right, so the greatest height it reaches is going to be this distance here, and I'm going to call that S. All right, now because we have a constant acceleration, which is the acceleration due to gravity heading down towards the ground, it's constant acceleration. Okay, then we can use what I call the Suvat equations. The Suvat equations. Okay, very useful for you to write Suvat, so you can write all the information we know, then we can figure out which equation we're going to use. Now, we're going from G, starting at G, going to H. All right. Now, what's really important for you in this type of questions is to understand that the S stands for the displacement of the object from the original position that it was at the start of our little section here. So the displacement is how far away it is from this point. Okay, if it's above this point, now you see you're going to have positive and negative values, which you have to be careful about, right? Especially in other parts of the question. So what I like to do, and what I advise my students to do always, is to take the direction in which the object was moving at the start of the section that you are considering as positive. As it was projected upwards in the beginning, I'm going to take up as positive. I don't always take up as positive. It depends on the situation. So at the beginning of the journey, when it was projected, it's moving upwards. So I'm going to take up as positive, and I'll mark that here. So I'm taking up as positive. All right. So the distance is above h, so that s is going to end up being a positive value. We'll see that from our calculations. U is the initial projection, which it was thrown upwards. So that's going to be 20 meters per second. Now, V is basically the velocity when it reaches its highest point, which of course is going to be 0 because it's going to be thrown up and it's going to decelerate because G is acting downwards until it reaches the highest point that it can, and then it's going to start falling down again. When you throw something up, it falls down again for this reason, because it's constantly being pulled down towards the earth. So it's thrown up, okay, and then it slows down until it reaches 0 velocity. So up here it's going to be 0 meters per second, and then it comes down again. So V is 0, and A is the acceleration due to gravity, which is down, and we've taken up as positive, so I'm going to put here negative G. I'm going to put the value of it at the end. And T, we don't really have to find what T is, okay? What we have to concentrate on is finding what S is. It told us to find S. So we have to have an equation which deals with S and U and V and A for us to find this greatest height, which is we called S. So if we look at our formula sheet, we'll see there's an equation that involves V, U, A, and S, which is V squared equals U squared plus 2AS. Let me make that look more like a U, it looks like a 4 there. All right. And after a little while of doing these questions, you won't really need to look at the formula sheet, but it's there in edX. In Cambridge, it's there. In Edexcel, it's not. They don't have these formulas in Edexcel in the formula sheets. You have to know them. Okay. So now, V squared equals U squared plus 2AS. So we can just put the values in now. So V is 0. So U squared equals, 0 squared equals 20 squared plus 2 times minus, now in Cambridge, we're going to use 10 times S. All right. If it was Edexcel, we put minus 9.8 here. Cambridge, we use 10. So you have 0 equals 400 minus 20S. So we can say 20S equals 400. Divide both sides by 20. So you're going to end up with S equals 20, okay, because you have 40 over 2. So S is equal to the square root of 20. Okay, so if we find the value of that, that's it, square root of 20. No, why did I say square root of 20? It's just 20. Why am I saying square root? Sorry about that. I'm getting confused for some reason. It's early in the morning here. Okay, so it's 20 meters. Okay, S equals 20 meters. Okay, I don't know why I said square root, probably because I saw square up there. That's been used. Okay, so S equals 20 meters. That's the greatest height above the ground reached by P, 20 meters. Okay, so there's the answer to part A of this question. Right. Now, for part B of this question, it says find the total time from projection until P returns to the ground. Okay, so the total time from projection until P returns to the ground. So I'm actually going to use this diagram. Okay, I'm going to use this diagram. Let me just do this. Okay, so here we have second, here we are. All right, so it's been thrown up, okay, and now it's going to come back down again, right? So it's going to come back down again. So it's going to come back down. So it's gone up and it's going to come back down. So let me just draw something to show that. All right, so it's going to go up and then it's going to come back down. All right, so it says find the total time from the time it was projected until it returns to the ground. Now, there's numerous ways that we can do this, okay? And we know S is 20 meters. All right, there's numerous ways we can do this. We can find the time it took to get to the top and double it, okay? And that's pretty simple. We could use V equals U plus AT, okay? And we know V is 0 from G to H. And U is 20, and A is minus G, and we're going to find what T is. Okay, so we can say 0 equals 20 minus 10 times t. So we can say that 10t equals 20. So t equals 2 seconds. So therefore, from G to H back to G, it's going to be 4 seconds. All right, because it's going to take the same time it took to get up to come down. That's one way of doing it. That's one method, and that's fine. A second method is to think about going from G back to G again. Okay, and in this case, for this you have the same pseudo values that we had up there. Okay, we'd have exactly the same pseudo, but for this one, G back to G again, there's going to be some difference now. S, U, V, A, and T. S in this case is going to be 0, because when it gets back to G again, it's going to be in the same position from where it started. So this displacement will be 0. Displacement is not the distance it's traveled, it's how far it is out of its position. So if we're thinking about going up to G, up to H, and then back down to G again, the displacement would be 0. The initial velocity would be 20 meters per second, and the final velocity, when it's reached just before it hits the ground, is going to be negative 20 meters per second. Why? Because when it was thrown upwards, so we take it up as positive. So V is negative 20 meters per second, which is going to be, why is it negative 20? Because it's come back down to the same level. All right, so its speed will be the same as when it was thrown. If there's no air resistance or any other kind of resistance to motion, as we can assume in this question, it's reached down here, its speed will be minus 20 by the time it reaches down here. 20 downwards, so minus 20. And the acceleration is due to gravity. I'm going to take it still as minus g. Why? Because we considered what was happening when it was first thrown in our situation. So from G to G, it's going up at that point where we start. So we take this as negative because up is positive. And T is what we have to find, right? So here we kind of spoke for choice. We have many different things we could use. We could use V equals U plus AT. And V is minus 20, and U is 20, and A is minus G times T, what we have to find. So you're going to end up with G times T equals 20 plus 20, which is 40. And we know G is 10, so 10T equals 40, which means T equals 4 seconds. So we get the 4 seconds directly by using G to G. Here we took G to H, and we knew that the time going up will be the same as the time going down, back to the same level if there's no air resistance stuff. Okay, and we get T equals 4 seconds. And there's a third way of doing it, which it's a bit longer, but it makes us understand. And again, we take G to G. We start from G and end at G. So in fact, it's kind of like using the same values that we use from here. So we can use the formula S equals UT plus a half AT squared, right? Now, again, the displacement, if we're going from G back to G again, is 0. Initial velocity is 20. T is what we're trying to find. Plus a half times A is minus G, which is we call minus 10, times T squared. We end up with this quadratic type of equation. So you have 0 equals 20T, and that's going to be minus 5T squared, right? So if you solve this equation, you can take 5 out as a common factor. In fact, 5t, in fact, you can divide by 5. If you divide by 5, this is going to be 4t minus t squared. And then we can take out t as a common factor. So t times t minus 4 equals 0. So we get two answers. We have either t equals 0 or t equals 4 seconds. So t equals 0 is the time when it was at this level when it was first thrown. And t equals 4 is the time when it returned back to this level after going up and back down again. So our answer is going to be t equals 4 seconds. So all these three ways are perfectly good ways of finding the time it took from when it was projected to where it fell down again, right? Now, the first two ways, they use your understanding, or the first way, basically, what does it use? It uses, your assumption that it's going to take the same time to rise as it does to fall, which is true when there's no air resistance. And the second way, it uses the fact that you understand that when it falls at the point where it's about to hit the ground again, it's traveling at the same speed as which it was projected, but just downwards instead of upwards, going down. So it's same magnitude. So if we take it up as positive, then its speed on the way down, v, will be negative 20. right? And 3 uses the fact or the assumption, well, uses the fact that the displacement is 0, okay, when it returns back to its original position. And we use that to find, and this gave us 2 values. One was where it was thrown, and the other one where it fell back down to its position. Okay, so that's 2 ways of answering this question, and that's it. That's question number 1 completed. Right, so it's quite a simple little example of acceleration, vertical motion due to gravity. So I hope that was clear. And as I said, I'm trying to explain things in a bit more detailed way rather than just being a talking mark scheme. Okay, so I hope that was clear. Other questions you want to find from this specimen paper will be in the playlist that will appear in this section here. If you click on it, it will take you to the playlist for the specimen paper. Other questions which are dealing with constant acceleration, and I guess I'll maybe make a separate playlist about vertical motion under gravity. You'll find that in the playlist that will appear here. Other questions, or if you would like to subscribe to my channel, you can click on this link. And if you would like to watch a video that tells you how to use my channel to find the things that you might be looking for, whether it's IGCSE material, Edexcel, A-level material, whatever it is, the video will explain how to navigate through my channel efficiently. Thank you for watching, and see you soon.